Welcome to The Explainer. You ever wonder how an AI masters a really complex skill completely from scratch? Well, today, we're going to unpack policy optimization. It's basically the brain training method that teaches an AI how to think, strategize, and ultimately, how to win. So let's just dive right in. When we say an AI learns to drive a car or play a game, what is really happening inside its digital mind? Is it just, following some giant list of pre-written rules? Well, the answer is no. It's actually way more fascinating than that. The AI isn't given the answers ahead of time, it has to discover them for itself. It's literally building its own playbook from the ground up, entirely through trial, error, and feedback. It's learning from experience, a lot like we do. Okay, so to really get how this works, we first need to meet the key players in this whole learning game. You can kind of think of it like a play with two main characters. All right, first up, we've got the agent. This is our learner, right? The AI system itself. Think of it like the student in the classroom, or maybe a robot on a factory floor. It's the part of the system that looks at its surroundings and then makes a decision. And of course, every agent needs a world to live in. And that's what we call the environment. It's literally everything the agent can interact with, from a chessboard to the chaotic streets of a city. And this slide here, it shows that relationship perfectly. The agent is the active decision maker, that car's AI deciding when to hit the brakes, or the trading bot deciding to buy or sell. The environment is the whole world it has to deal with. See, the agent does something, and the environment, it reacts. It presents a new situation, and hey, sometimes it even gives out a reward. Okay, so how does the agent figure out what to do? That, my friends, is where the policy comes in. The policy is basically the agent's brain. It's the strategy. It looks at the current situation and decides what to do next. A good policy, that leads to success. A bad one leads to failure. And the whole point of this entire process, it's to find the absolute best policy possible. All right, let's dive into how this policy actually goes from just a bunch of random guesses to a killer strategy. And you'll see the basic learning loop. It's surprisingly simple. We can break it down with a really easy analogy. Okay, picture this. You're learning to golf. Your swing, that's your policy. You take an action, right? You swing the club, and then you get a reward. The ball flies 200 yards down the fairway. That's a huge reward. So what do? You update your policy. You try to do more of whatever just worked to make it happen again. And that right there, that's the simple but super powerful idea at the heart of all this AI learning. If it works, do it more. If an action leads to a good outcome, the AI tweaks its internal strategy to make that action just a little bit more likely in the future. But, for an AI, it's not just a gut feeling. It's a super precise mathematical calculation called the policy gradient. You can think of it like getting feedback from the perfect instructor. It doesn't just say, hey, good job. It tells the agent exactly which knobs to turn, which internal settings to adjust to make that good thing happen even more often. So this basic trial and error thing, it's powerful, for sure. But man, it can be slow and kind of unstable. I mean, sometimes a good outcome is just a mix of a few good moves and a few lucky breaks. So to make learning more efficient, researchers gave the agent's brain a serious upgrade. So what they did was pretty clever. They split the AI's brain into two parts that work as a team, the actor and the critic. The actor, well, that's the doer, the student. It's the part that actually swings the club. Then you have the critic, that's the instructor, who's watching every single move and giving feedback right away. It doesn't wait to see where the ball lands, it judges the action itself, instantly. And this teamwork, this actor-critic duo, it's a total game changer. Because the critic gives feedback instantly, the actor starts to understand which specific moves were good, not just whether the final shot was good. This stops the AI from getting confused by, random luck or waiting forever for a result. It makes the whole process way faster and much more reliable. Okay, but even with this awesome upgrade, there's still a pretty big risk. What if the AI gets super lucky one time, has this amazing run, and decides, hey, I'm going to change my entire strategy based on that one time? A single huge update could just wipe out all the careful progress it's already made. And that's exactly where one of the most successful techniques in modern AI comes into play. It's called Proximal Policy Optimization, or PPO for short. And it was designed to solve this exact problem of taking learning steps that are just too big and too risky. This slide really nails the core idea of PPO. It's kind of like a super cautious instructor. It puts up these mathematical guardrails on the learning process. This makes sure the AI only makes small, steady improvements, instead of taking these huge, risky leaps. It keeps the training stable and stops the AI from forgetting everything it's already figured out. So, okay, why should you care about all this technical stuff? Because this brain training method, especially these advanced versions like PPO, this is the engine that's powering some of the most mind-blowing AI we see out in the world today. Take self-driving cars. The AI agent learns its driving policy by driving millions of miles in a simulation. It gets points for a safe, efficient trip, and it gets penalties for messing up, like leaving its lane or, crashing. Over time, this process fine-tunes its strategy to handle some incredibly complex situations on the road. This is also a huge part of what makes models like ChatGPT so good at what they do. There's this process called reinforcement learning from human feedback, and it uses PPO to fine-tune the model. Here, the policy is all about choosing the next best word. And basically, it gets a reward whenever a human says, "Yep, that was a helpful and safe answer," which teaches it to be a better conversationalist. And then you've got robotics. Policy optimization lets a robot arm learn how to do really tricky physical tasks. The agent figures out a policy for moving all its motors and joints, getting rewarded for successfully picking things up and moving them. This lets them learn skills that would be practically impossible for a person to sit down and code line by line. So if there's one thing to take away from all this, it's this. Policy optimization is how we teach AI to solve problems that don't have a simple step-by-step answer. It allows us to just give the AI a goal and then let it figure out the best way to get there, all by itself, through experience. And that leaves us with a pretty cool final thought. As this whole brain training thing gets better and better, that line between what a machine can learn and what it can't, well, it's just going to keep moving. So I'll leave you with this question. What's the next big human skill we're going to teach a machine?